Yeah. Are the vertex buffers a part of the pipeline or not? How is the characteristic range the pipeline owner? Yeah. It's a factory owner. Yeah, okay. Hello, Motto 4. Trying to understand my own code. One of the 2 test applications that I wrote so far calls create vertex buffers. The other one doesn't have vertex buffers, so. And what this does, I think, just creates tables with vertex coordinates. Well, it creates vertex buffers. Yeah, creates vertex buffers on the GPU and fills it with data that comes from the data feeder here. Vertex shader input set feeder. Takes a vertex shader input set base pointer. Vertex shader input set. That's just this loop variable, which gets its stuff from the input shader input data object. The vertex shader input sets. which are pushed back here by calling add vertex input binding. Okay. The names are a bit vague, I think, but what that the word binding here is now definitely confusing me. Oh, okay. It creates a new binding. Let's have a look at the resulting shader code. Maybe that makes things more clear. What are you doing here? This is IMU. Yeah, so this is the vertex data. Or maybe just the instance data is very closely related. Maybe just these two. I think the only reason I have an array here is to test that. Because we're only really using index 1. Oh, someone's calling on my door. Be right back. Sorry about that. Someone at the door for edit, asking for money. What else? Compiling. Yeah, so I'm only using index 1 of this array. It seems so. It's not really an array. And then that vec4 is position. Still confusing me a little bit how this array works. Let's have a look at this. I can jump to it directly, I think. Vertex data and position. Yeah, it's just an array, 3 size. Okay, this is how it is filled. So there is an object called heavy rectangle. Which makes these, well, rectangles, I guess. Even though this looks like a square to me. So that's these things here. Yeah, they're totally squares, not rectangles, if you ask me. And the way that that makes it into my program is as follows. The application window is a user class which defines the window derived from, but that has an object which is added at some point. Another one is the random positions, because those squares are put randomly over the window. That's per instance data. So at the moment we call add vertex input binding. The binding is really a location, I feel. I didn't see back in the shader any binding, only a location. Vertex shader input set base pointer. follow it. Add vertex attribute. Binding is passed. Still call binding here. Used to initialize. What is being initialized here? Shader builder vertex attribute. The last argument. Also called binding here. M binding. I also have binding functions that call an uint. That's related to the set, descriptor sets. The only place where I see that it is being called is this one. And then it is casted to an uint. This one is related. So in the end we get here with that binding value, and we call it still binding. And apparently it's not location, because location is there. What the hell is this binding then? It is binding. It is passed to vertex input attribute descriptions. Now rather used for this thing here. Vertex input attribute description. We have a location, a binding, a format, and an offset. And I have no idea what binding is, really. Probably should have, because I think I just forgot it. So I wrote that, and then I knew what binding was, no doubt. Loading this page takes a while. At least. No, this is not the page that I meant. This is just the or is it still loading? Chapter 3. Yeah, damn it. I want everything on one page. There we are. This one. Why is not just everyone? This is, I was looking for a link. Finally found one. Okay, so here we're binding. Binding is the binding number, yeah. which this attribute takes its data from. Yeah, it doesn't explain anything, does it? Vertex input description. Applications specify vertex input attributes and vertex input binding descriptions. As part of a graphics pipeline creation, by setting the VK graphics pipeline create info p vertex input state pointer to a VK pipeline vertex input state create info structure. Alternatively, if the graphics pipeline is created with VK dynamic state vertex input ext dynamic state enabled, or with the dynamic state enabled, then the vertex input attribute and vertex input binding descriptions are specified dynamically with the VK command set vertex input extension. And the VK graphics pipeline create info p vertex input state pointer is ignored. I'm not doing that at the moment. I think so. The VK pipeline vertex input state create info structure is defined as, and then inside of that we have another pointer which points to the VK vertex input attribute description. What do we have here? We just have flags not used. Count is the number of vertex binding descriptions provided in the vertex bindings descriptions pointer. So basically it passes two vectors, the size and the pointer to the beginning, and another size and pointer to the beginning. From this you understand that this vector here contains elements with binding numbers that must also exist in this one. Or maybe the binding is the index into this vector. Not sure. All elements of P vertex binding descriptions must describe distinct binding numbers. Oh, okay. It is so not clear. Binding descriptions must describe distinct binding numbers. I just really want to see that structured by now. P vertex attribute descriptions must describe distinct attribute locations. Can only have two values, either per vertex or per instance. The rate here. The stride, okay, that is the size of the elements, basically, or at least the distance between them. Binding is still not clear. Maybe the binding is related to a binding of the descriptor sets. I think could be like it reversed to a buffer, vertex buffer. Well, basically the specs are so unclear that I have more chance understanding this by looking at my own code, which, if things are correct, is already doing the right thing. I just forgot how it worked. This doesn't tell anything. Binding is the binding number. That's about what we get. So the vertex attribute descriptions. This is the vector, one of the vectors. That gets filled with binding numbers that we get from vertex attribute, which is from the table that we iterate over. In other words, this table. That is a GLSL ID. Why no comment here? Maybe you can see an explanation close to the binding index. Well, no, I can't. Wherever this is used. That's a really mysterious thing, this binding. But the binding is a binding index, and the index is being used to store vertex shader input set base pointers. So you can also grab for that. And then we find this. Finally something with a comment. Vertex attributes. Yeah, we have a vector of vertex shader input set base class pointer. Existing vertex shader input sets. Namely a binding slot. Newton, 46 years. Starting at 1 hour 12. That was like from before C++ existed, I think. Well, my last hope is that there is something close to where we're drawing that shines light on it. This is the wrong application. I need the other one and not the uniform buffers. This online, I guess. Here we have something. Vertex buffers. Grid, well, welcome to the club. I don't think you missed anything, Poshinski. Poshinki. Yeah, man. I'm seeing here an index, 0 and 1. And they refer to two buffers. Maybe that's the binding number. And that is an read lock and vertex buffers. Which is a vector of vulkan memory buffer objects. So I guess not. Not a binding number then. Command buffer is the command buffer into which the command is recorded. First binding is the index of the first vertex input binding whose state is updated by the command. Binding count is the number of vertex input bindings whose state is updated by the command. The values taken from elements I of P buffers and P offsets replace the current state for the vertex input binding first binding plus I for I in 0 to binding count. Okay. That finally tells us that there's a relationship between some binding number and a buffer. And an offset apparently. Okay, finally my memory is doing something. I very vaguely remember that, and I might be mistaken because you have no idea how vague this is. But some shortly at the back of my head, something surfaced for a short moment. And that was that these binding numbers are local to the command buffer. So that's why we did not see them back in the shader. On the other hand, if you rebind vertex numbers, then they must linger somewhere. So in this case I'm using 0 and I guess then the size is simply taken from this vector here. And these are the offsets. So the size of these two must be equal, and both have a size of 2, so that is correct. And then we are replacing binding number 0 and binding number 1 with this buffer and this buffer, offset 0. I think the offset means offset into the buffer, so we just the whole buffer, from the start of the buffer. And they are being bound here. So a binding refers to whatever buffer you have bound. In that sense, I would say that this index kind of is also a binding index. Well, in this case, it literally overlaps with the 0 and the 1. But yeah, I do not understand that enough to draw that conclusion. You gotta wonder what would happen if I switched the two, just for the heck of it. If I have two vertex buffers, I only think I have, I might call them vertex buffers, but they are probably either per vertex or per instance buffers. So this could be a buffer that contains all the coordinates of my heavy rectangle, and this contains the coordinates of the random coordinates. So I guess if I swap them, then it crashes because the size is not equal. I want to try that. That's a quick crash. Apparently doesn't think that one of these buffers is contains valid buffers. No idea what this is. Oh wait, I put 2 in it, sorry. I wanted to swap them. Try it again. Well, okay, it's not crashing, but it's also not drawing anything anymore. Absolutely nothing. So it would have been nice to see that we got some random draws. Well, I could still check that. I think that we just do this, so use the same buffer for the rectangles and for the positions, and at least the position should not change. So if we get nothing, then I don't know, but maybe you get some random looking rectangle now. Hello Christopher and Lendy, Electronic Moonish. Still nothing here. Okay, well, whatever. Was a nice try, I think. Yep, back to normal. Okay, begin for the start again. I'm working on this FIXME, which says that it seems weird to call this here because create vertex buffers. That's what is being called here. Should only be called once. And that's generating the coordinates, I guess. It's generating and uploading the coordinates of 2 vertex buffers. So the coordinates of the heavy rectangle and the coordinates of the random positions to the GPU. Uploading. We only want to do that once. But currently we are inside the pipeline factory. And I did this, yeah, okay. In this case, I'm checking that here. We only get there once, but so that is strange. This call should be done from somewhere else. I think in the other application that I have something similar. let's say if you look at the other application that that does not have any vertex buffers, so this is going to be missed, I think. We'll go straight from setting the topology to calling realize descriptor set layouts, and this will be missing. That's my prediction. This is going to be an initialize function of a pipeline characteristic. I could grab for this function, but I want to grab for the initialize. Okay, it's called initialize X here because being called twice. And indeed, we go straight from setting the topology to calling realize script set layout. Now, that doesn't say much because we don't have vertex to begin with, but I'm pretty sure that this application also has some code that must be called just once. And I'm curious if I can find back what that was. And then how or where that is being called from. Could be any of these functions, maybe this one. Create textures. Create render graph. No, that's too far back. I think create textures is also not it, because this one also has a create textures. Yeah. And that is already being called separately. FIXME. Yeah, I have a Discord. You can join it. It's not much chat's going on, and I'm always having it buried under my OBS. Probably should not do that. It's probably a good thing that people are not using it, because no time for chatting. The only advantage of Discord is that it is a way to contact me outside of the streams, and especially each other. In the past, chat was going on in the chat, and then I stopped the stream, and then people had to stop chatting. I have no idea what a Valorant is. if you were running Linux and you're talking about the Mac of your Ethernet card, I don't know how that works. When I was still using a Second Life, and I was a coder for Second Life viewers, so I knew a bit how it worked. Basically, they sent everything to the server. How many RAM you have, what GPU you have, what GPU card, what your CPU is, what the MAC number is from your Ethernet card. Everything they could get. So yeah, I changed my viewer to send random data depending on my login. So if I would log in on one account, I would seem to have a completely different PC, even though I was having the same PC. Then when I would log in on another account. It saved me once because I was banned at some point, of course. And then they left all the other accounts alone. They just didn't know that they were really the same person. I have to do something like that in advance, you know. When you do it, when you start thinking about it after you're banned, you're too late. But yeah, I mean, those bans normally don't work. You can just spoof your hardware ID, but I cannot tell you how. Google it or something. And I forgot again what I was doing. All right, I was looking for one-time functions. I think I should look in the pipeline factory instead. What is this doing? Okay. That screams scammer. Team viewer of AnyDisk. Yeah, goodbye. You really think I run Team Viewer or AnyDisk on my Linux box? Why is this pointer passed? It's just a pipeline owner. I don't think I'm using an IDE. Or I'm using my own bash scripts to automate a lot. Maybe that's my IDE. The pipeline owner is passed, and that's being used to access the shader input data object. But it is also passed to the set data feeder. Let's look at this one first. Okay, so this uses, vertex shader input sets. Which are being filled by calls to add vertex input binding. Which are being called here. So inside this initialize, I'm adding the heavy rectangle and random positions thing. And then below that we call create vertex buffers, passing to this pointer so that I can get back to what I just added. So I cannot call this before calling this initialize. Now that makes you think that it belongs in this function because it's using data that we just added. The only doubtful thing is that if I would have a different pipeline that also added the same objects, these two, then I would not want to upload them twice. I would want them to share the vertex buffers. So initialization is some initialization needs to be done only once, and possible other threads have to wait until that is been finished, and then they can use it. It's kind of like a standard call once thing that I could use here, but I don't want to block anything. Yeah. I'm not using C-line, no. So what I would really want to do is we enter this function, maybe with multiple threads. I think if that is possible. Each vector is only calling it once. So these things are part of the characteristic. And I think that for a given instance of a characteristic, initialize will be only called once. I mean, it should be as simple as that, right? I mean, it should be as in, otherwise it becomes a bit error prone. I just have an object here that has a member. Initialize is being called once, just like a constructor would be. And that then initializes this, and in this case that means it uploads it to it uses this instance and whatever it defines to upload something, to upload a vertex buffer to the GPU. And the only problem I would have is some other characteristic object would use the same heavy rectangle. Or when the code would use multiple instances of this object, in which case I also would have multiple instances of this heavy rectangle. Yeah, and these things form a whole, I must say. Do we add it? And this is more related to telling the shader that we are using for this pipeline that this is being used. I guess I could do without this call if I had duplicates. I'm afraid that the only way to really figure that out, or test it rather, is to use this twice. I could do the same as in the other test application, and I just divided the window in two parts, and one pipeline draws to one half and the other pipeline draws to the second half. If I would do that here, then I could just use 2 pipelines, both use this characteristic, and then we would have a duplicate of these things. And then see if we can get it to only upload it once. Something like that. And then the upload is related to calling this. So then this must be only called once. But now in more abstract, more in general, I keep running into the problem that I want to have a function that is called from a task, an AI stateful task object, and I just want to halt in the middle of that function. Now I can do that if it is inside the multiplex. But if the multiplex is calling my initialize, it's kind of difficult to leave the function in the middle of here and then later return to that same point. Unless I would add a switch here as well and then make it a re-entrant function. I think that the original design is that I would have to make a separate task. So I would have to turn this initialize into a task. That is what I should do according to my own stateful task design. And that then means that I have that I should turn my characteristics into tasks. Ouch! Really? This becomes interesting, complex. What else is a characteristic doing except initialize? Print on. Nothing. Let's have a look at the base class. Oh, we have a fill. Yeah, it's got probably the same story for the fill then. Really interesting, really interesting. If the fill is not there and there was only initialize, then I could just turn the whole thing into a task. My task works, the task design more or less works as follows. You create a task, you initialize it, and then you run it. And then you should not touch it anymore until it is done. But it can interrupt. It can be interrupted itself, like in the middle, you can just return to the thread pool and then pick up later based on signals and stuff like that, I/O, whatever, which is what I want in this case. And when then, say, the initialize function would normally return, then simply the task finishes. And as a result of the task finishing, I can restart the calling thread as if initialize returned. But after that, I want to call fill multiple times. Now, if that's not a task, I mean, if it cannot be interrupted in the middle, then I just can call this function and keep it. But if I want to turn that also into a subtask that might, want to halt in the middle of the fill, then this same object would need to be again a task that is being run. I guess that's possible. I can just call multiplex with a different starting state. So yeah, maybe it's not impossible at all. Shall we do that? It's kind of a lot of work, but it might be super interesting, I think. See the result of that. Yeah, I'm going to turn this object into a task. Using my tasks are very easy, but writing them is not. Fortunately, I did write some documentation. And I think that documentation is on my website, but hidden. So I have to add here, I think, AI stateful task. Nope. Just stateful task. And now you enter the dark web. Yeah, there it is. Not linked. That's what dark web means, right? There's no links to it. Usage. Prerequisites. Pretty sure that we have that already. Writing a task. Okay, so it must be derived from AI stateful task. Publicly. Now, before I start an operation this big, I better make sure I have everything committed. I have everything committed. That's just a troop here. Okay then, guess we'll do it. I want to make my characteristic ranges a task. Now the question is, can I use the base class to do that and then have the derived classes implement their own multiplex? I don't think it is possible, but it would only make sense if the base class has its own states that it goes through and does it. I could use the base class to split my multiplex into two functions instead of asking the user to do that. So one for initialize and one for... I could literally change the initialize and the fill function to a multiplex function. That is, multiplex function is running task. Yeah. Think if that is worth it. Well, why not? When you make things more complex, you might as well make them horribly complex. So we want to be publicly derived from this class, and this class, it happens to be derived from AI ref count. So we don't need this ref count anymore. We do need to include stateful task / AI stateful task, because that is where this base class is defined in. And yes, it is strangely enough not in a namespace. There is a namespace stateful task though, but it's not where it is in. Not even in task? You could be kidding me. Nope, not in the namespace. Then we need to begin with this. Then we get the states of the task. State type, yeah. Cannot remember if I call those. Looks a bit different. Yeah, it's called like that. Logic revise state type. So yeah, we're going to call it characteristic range state type. Okay, and we're going to have the state initialize, I guess, and fill. Now we need a public the last state plus 1. We need to construct it, of course. We need a constructor that takes a boolean and passes that to the base class. And I think it would be nice to print it. This editor is new Vim. Let's see. And we need a virtual destructor, or the destructor is virtual now, but I don't have a destructor defined here, I think so. I don't see any. And then we're here. I need to define a function that's called like that. As well as the others as well. Multiplex. Really? Duplicate. Bad documentation. Okay, anyway, ignoring that bug in the documentation. Need to implement this one. Also old documentation. Pretty sure that it works, so it is use AI. Never reached. Let's see, we have and then the multiplex. Just the case of all of them, I guess. So case start. Papa. Well, we were turning these into their own multiplex, actually, even though I might not rename them. Blah. So now we cannot pass these things as arguments anymore. You have to use a object, a member object for it. I don't think I can set this. Sorry, where are my? Where are my normal members? Here, begin, end, etc. So add it at the top. I don't think I can initialize this flat create info thing during construction, so I'll make it a pointer. And I want it to be a null by default then. Let's put my state stuff here. Yeah, owning winner also does not change, so it can probably even pass it to the constructor, I think. Yeah, I think we can. Can we not? I don't know where it is constructed yet. I'm just gonna try it, you know. It said owner is called with it's the owning factory. Okay, well. Yeah, anyway, we strip this one of all these arguments now. And it's not virtual anymore, really, because oh, it is virtual, but well, still need to make this one index. Let's call that fill index then. Gonna add that at the end. Okay, now I need a way to re-enter this task, sometimes with start, but sometimes with fill. So I need to be able to set this, and I think that normally that should happen. I mean, I forgot how everything works. I just this stateful task thing is pretty complex. I'm starting to be a little bit scared to just, do things a different way. Although it should just assert if you do something wrong. But initialization implementation or not. Initialize implementation. You can set a state here. I don't think you can set state outside of it, so you'll just have to do it here. Well, let's skip the start. We don't even have a start. So I'm either setting this or let's say initializing. We set that state, and otherwise we set the fill state. So I need a bool initializing and also a setter for it. I'm gonna get rid of the start. No more start. Initializing. Oh, let's begin with true. Can combine that with this. Well, we can combine it because this is initialized as undefined. I don't even need the undo. I don't even need m initializing. Oh wait, it's an index type. It's an int. Horrible. Index type that is an int. Well. If it's still -1, then we start at initialize, otherwise we are starting at fill. think that's basically it in terms of that we turned it into a task, and that the task is now calling initialize and fill. So nothing really happens, nothing really changed, but well, actually one thing changed. We're now running in a task, which means that we're running in a random thread. That might be a problem, or not. Nah, it's not a problem. Plus, it won't be running in a separate thread, but it could be. You have to. In theory, a different task could run in a different thread, but because we're blocking the calling thread, the calling task is waiting for this one to finish, so there's no real difference. Plus, it's just going to use the same thread anyway. Yeah, so it did not compile because I only changed the class and not the callers. But I'm going to use compiling to find out where those problems are. Error, index type has not been declared. It's declared here. Okay. An index into the range that uniquely defines the value of the characteristic. Yeah, now I think about it. Normally I have, say, my private variables above functions. And now I put all this new stuff above that because I thought, it's use it for the task. But let's not do that. So I'm going to remove everything that is related to the task. We have a shader input data reference thing here. What the hell is that doing there? And why did my music stop? Okay. Back with music. I'm going to put it below the constructors even. This must be public, right? Hell, I might put it all the way at the bottom. I don't know what this is. Owning factory shader input data. Just an accessor or the shader input data. And it is protected for some reason. That's all public. Yeah, that's why. Well, not really, but yeah, and the type devs have to go at the top, of course. This is nonsense. This is nonsense, and it's not related to task either. First the type defs, and then the private objects, the private variables, and then the constructor. I'm just gonna move this. I thought it was just one of them, but then the constructors, and then the manipulators or whatever. I guess that below public I can put protected. This is task specific, so I'm going to put it here. Okay, finally we got through that header. Yep. Now this is an override, but we're not having these arguments anymore. So just delete it. Sorry, let's have a quick. More like an AMD guy. I believe that, I mean, it varies, right? But I believe that Intel often has is slightly faster. I mean, they really have the faster CPU, but then you pay twice as much. And they're only 10% faster or something like that. So it's if you know those the last 10% really cost a lot of money. You have to you have to go for I think the amount of Yeah, CPU power that you get per dollar, per euro. And then you will not be buying the fastest, the overclocked monster that they sell, just to get at the top of the list. Non-declaration matches cons pointer vulkan pipeline characters range state string implementation AI stateful task state type. Candidates virtual character cons pointer. I really don't see the difference. Oh, the cons is missing. It does not say here. Is there another bug here? Yep, another bug. The cons is missing here. Now I want to fix it. So keep ramping up these bugs. Where do we have the documentation? How about doc? And what was the other problem that I had? Forgot what the other problem was. Oh, right, duplicate constructor. Which I don't see anymore now. Because that was already fixed. Maybe not pushed to the website or something. Not sure how that works. I thought that should go automatically, right? Do I need to run some make documentation thing? Holy moly, it's not even compiling. Ah, my eye is burning again, like hell. I think I added the task name implementation pretty recently. Apparently I did not update this test thing here in the file. Task type. Let's put it there. Top. I see. That was the one, right? Yep. Silver, yeah. Work hard. Work harder. What are you doing here? Start working. Now I have to update every test that I have in this test suite, like this. It would be easier if we could get a listing of everything. Yeah, invalid new expression. Maybe that could bring us closer. That is nee. Yeah. State implementation. Still not on my task. That was all. Oh. Yeah. Then commit. So people that ask my IDE, well, this kind of shit, it's just automated by bash functions. But git status is no saying. I still have a modified content in file log task. Well, they should have added that as well. Git status diff. Oh, let's not do that. I know what went wrong, but well, they did commit. No, okay. Can I push or is it going to complain? Okay, that looks good. Do I have a make check here? Test. No, don't need testing. I wanted my documentation. I have no idea how to do that. Make help. Doc. There's a doc. Make doc. Warnings. Only warnings. I guess only warnings. Build target doc. So now I can go here. Choosing a make file, or am I completely crazy? No, it should see. Make list of text. Yeah, what to do? That's annoying. I don't know how to get this on the website. Unless... Yeah, there's an output directory. Aha! That's Saturday, 5 November. Right now, yeah, this was updated. So, I think I have to push this somehow. Git status is a Git thing. Looks like it is untracked, modified. Come on, I need to have a script for this. There we are. It doesn't look like it does anything with stateful task. No. I cannot imagine that I have to add these files by hand and then commit them. Maybe this gives an idea. Git add lib ECC. Aha. Yep. What happens if I do git add stateful task? And then we do a git status. Now we have everything. Well, hopefully that worked. Although, when does it appear here? We don't know. Not yet, anyway. Oh, wait, I did not... I did not add this task name yet. I should not have to add it here because this is going to be only a base class. It really should be overridden in the derived classes. So yeah. But for now, you know, to get it to compile. Yeah, 3 squares. I'm working on the Vulkan engine. That is, I was working on the stateful task library for a bit. But now we're back to, if you see a Linux viewer here on my prompt, then it's a Vulkan engine. No matching function for call to Vulkan pipeline characteristics initialize. Finally, go back to expected errors. So yeah, now this has to be done in 2 steps and 3 even. Yeah, I was trying to pass the window owner to the constructor. I was hoping I could do that, rather. To the constructor of the characteristic, which means that wherever that thing is created, which is far, far away, intrusive pointer to characteristic range. Pushback. Move. Still intrusive pointer. Pipeline factory add. Characteristic ranges. Yeah, that is not findable. This is too short, his name. Let's just rename it. Um, Okay, more flat create infos. I don't think I have to set a flat create info again here, right? Already did that when calling the initializer. I'll guess this is a pipeline factory, so I guess this is the 2. And down here we have a missing owning window, right? So yeah, we have the window here. That is a good thing. So cons reference. No, expect 0. Yeah, I have to fix this one. The default has a range of a single entry. On this one is not a range. I think I have to explicitly define it, passing the owning window. Task. Task synchronous window const pointer owning window pass to characteristic range. Yeah, that looks good. And I get a range of 0, 1, aka no range. It compiled. Okay, now we have loads of problems. Only now I realize that. Uh-oh. There's a lifetime problem, maybe. This is like the only place where they are created, the characteristics. Yeah, it is just too short. Although now I have duplicated names. Damn it. This is also called add characteristic. Yeah, I don't know. It's pausing, calling, object A function name X calls object B function name X. And it's doing nothing else. Maybe they should be the same name. Yeah, okay, so the problem is that, potential problem I should say, I guess, is that now I change this characteristic into a task. Oopsie, big change. I'm passing it to add characteristic, which after calling make C tags will show us that that is the old add to. We're calling add characteristic here, which is this function, which takes an intrusive pointer. So the reference count is incremented by 1, that's good. Now we call push back with a move. I take it that C++ has a move operator for pushback. And then we get then it is added to characteristics, which is this type, which stores boost intrusive pointers. It's like it was made for tasks. It's amazing. So the task is only deleted until this is deleted. It must be deleted again from the vector. And that only happens, I think, when the pipeline factor is done and destroys itself. But well, that's good enough. Not really a problem with that. Okay, so actually there's no problem. I don't think there's a problem. Yes. We're not using it yet though. We are calling initialize instead of running the task. So what I should do here is call run. And that gives an immediate problem because I can maybe start multiple tasks. It's scary. Each of these characteristics then would run in parallel in their own thread. And the main problem is that I want to wait for it, right? I don't want to continue on while these things are still running, still calling initialize. I'm not sure I have a provision for that already. I should have. If I have, I cannot remember it. It does not pop up. I think I have the Fibonacci tests that we even saw today while I was working on the library. That kind of does it, I think. I start two tasks. Say Fibonacci number capital N is Fibonacci number n minus 1 plus n minus 2. And I implemented that as tasks. So a task then starts, a task calculates the Fibonacci number n by starting two tasks. One for Fibonacci number n minus 1 and one for Fibonacci number n minus 2. And when both finishes, it adds the results. That's what I remember. So that example, but that's from long ago. So yeah, you never know if then I had an improvement in the meantime. But at least that one is waiting for two tasks to finish. In this case, we have to wait for a number of tasks. Yeah. You would think I have a provision to wait for multiple tasks. Either one of the tasks is finished or all of them are finished. Vaguely remember that I worked on that somewhere in the past. I mean, mind you, I wrote this in the past, somewhere in the past 12 years, right? So sometimes it's years ago that I wrote it, that I worked on that. Anyway, if we enter here, top of multi-loop for loop. Then either we set run state directly to bottom, or we set it to a while loop. I don't think we'll ever set it back to this one. Set state, we do. Oh, definitely do. Yeah, that's really the top. So we're going to need a new state, and that we will execute once after all the initializers have been finished. Now this one is already called initialized, but there was a different initialization, I guess. It's more the pipeline factory initialization, and this is then the characteristics initialization. I don't know how to do something here, and then we just stop. And here I'm going to add a new thing, what is called characteristics initialized. So once all these tasks here are finished, then we should continue here. That will be the same thing as if it was just a simple loop calling a function, right? So let's add this new state. Okay, now I need a construction such that we will continue. Well, before I do the break, I can set the state to where I want to continue, like this one. But we also need a wait. So this is where we want to continue, but we're not going to continue until we reach the condition or whatever I passed the wait here. So let's invent something. Here I have one pipeline cache setup. I already have a fully initialized, really. See what that is. Oh, there. Fully initialized. Yeah, well. So we're gonna wait for the characteristics to be initialized here. And apparently because I need a return instead of a break. Yeah, leaving this function. And then when this signal happens, we continue here. And the signal then should happen once all of these tasks finished. Let me think. Didn't add this one yet. So add that below the fully initialized. Okay. Actually, I think I just have to make... no. I would say I have to wake up the parent every time and then just count if they have all finished. Sounds a little bit inefficient though. Can also make it call a lambda callback function, and then have the lambda call count down, and if it is done with counting down, then it signals the parent. I think that is yeah, always a solution, unless there is already a official support for it, which I cannot remember at the moment. I'm going to look at let's test it again. So I had the Fibonacci, for example. See, this runs 2 tasks. Runs 2 tasks, and both subtasks signal the same bit. So that is going to be, the parent task going to be woken up for both. And then it just checks if all of them are finished. Now, that's a poor man's wake up, I think. To wake up every time. Seems to make more sense to just have a counter. It kind of smells like a condition variable, doesn't it? Condition variables are also counters. Do I not have support for condition things in my task? Semaphore maybe. See how that looks like. Doesn't seem to have anything to do with tasks. Just a real semaphore. Yeah. There's nothing here, I think. Nope. Let's use this one. Oh, just pause a lambda. So every time one of the subtasks finishes, it calls this lambda. And then the last one should call my signal on the parent. So we have the parent is this, so we need to capture this. Now, after having captured this, we can call signal. To this signal thing. Now I hope that signal is, well, now the first one does it, or all of them does, but I'll fix the code in a minute. I'm just wondering if signal can be called from this lambda. I think so. I think signal can be called from everywhere. Central task here. Signal. I have an actuation there. What is that? Okay, this is a faster support for the superior's wake up. I could just have every sub task wait up the parent task, and then using the parent task to wait until, and that would be faster than implementing it myself. But still. Signal is public, okay. There is not much public. Abort is public and signal is public. That's probably it. Right, so that is allowed. Let's try to compile it. Not that it is working like this, but if it compiles, that's already nice. Compile. It's not compiling. No matching function for call to vulkan pipeline characteristic range run. That's the one that I wanted to call. It takes a boolean. Oh, it passes a boolean back. Yeah, of course. I think that boolean is whether or not the task finished successfully. So that worked. Now we need a counter, and the counter must be shared, of course, between everyone. And it must be atomic. So let's add a static atomic int. Yeah, just gonna call it counter. And we have to initialize this thing with the number of tasks that we're going to start. So that would be just equal to the size of this thing. The M characteristics is a vector. So it's going to give me a narrowing conversion again. Warning, get sick of that. Let's do just an atomic size type. So the loop is only one large. We start with I begin, which is always 0. At least I think that is this one. Addition task. It really should be. So unequal, yeah, the size is just the number of times you run through it. So if the counter is set to 1, we get here once, and we will only be called once. And then you can ignore the success or not, because if any of them would return false, we have to collect the success. Okay, I'll make a boolean here. Success is true. So we grab this, and the rest we grab by a reference. Meaning I can just access success here, and I want to set success to false if S is false. How would you do that? And with S. So even one of them returns false, then the total success is also false. And now we can do if, counter, so minus counter, so we need a you don't have that, I think. Let me think. Yeah, we only have post decrements for atomics. Oh, that's okay. So I do counter minus equals 1. That's the previous value. So if this equals 1, then the counter head just became 0. And then we can call a signal. Yeah, I think that works. Yeah, now I cannot use success here because we entered a new scope. How annoying. Really? There's no way to access that. So if I want to do something with this success, then I have to blah. I know a better trick. To do it from here. Let's split this thing up. Think that we can do the abort actually immediately. You don't even need a signal for that. But the rest keeps running, so then we would be calling signal anyway afterwards. I don't think that's a problem, but well, let's say you call abort first. Abort just sets a flag. See if you can find that back here. Abort calls seems to be doing a lot. Yeah, it does some Boolean stuff. And we are waiting, right? So if waiting and not self-locked, then insert multiplex, insert abort, which is also doing nothing. Well, okay, it's complex, but in the end, it is pretty fast. Nothing is doing a loop or anything, just some bit filling and stuff. And unfortunately, mutexes, but they should be unlocked, not contest each other. So this function, what I was saying is this function just returns immediately. But it set a flag then that task should abort. Now, if then you call signal on it, signal also does not do anything. A lot less even. This is signal. Well, more bit fiddling. And might schedule a run. So it's not self-log schedule a run. Otherwise just return true. I don't want to look at it. It is a working code that I do not want to look anymore at. But yeah, I think that what I want to say here is that we can call signal on a deleted object. We need to increase the reference count on this task when passing it to the lambda, unless I only call abort after the last signal. Yeah, so I cannot move the abort here, but you have to do it afterwards. And even this then. Although probably it's safe to call abort and then signal, because they just set flags. But I'm not sure. Signal schedules a run. So it might already start running then. Well, I want to abort it. Yeah, that's also true. I think I have to call abort before signal. Is abort not scheduling something? I think so. Yeah, insert abort. Insert multiplex with insert abort can be called. What is that doing? That calls multiplex. Event type is abort. Insert abort. Uh, Macra asks, how can you stay that much time focused? Yeah, I can only when it's silent. I'm very sensitive to outside. What is the English word? Prikkels in English. So I'm having a headset up, sitting in a silent room, and then a headset with anti-sound. I cannot look outside, so there is absolutely nothing that I can hear, feel, or see other than my monitor and the music that I'm listening to, which do not contain any vocals. Well, in general, I wrote my task engine such that you cannot make a mistake, and I should just trust that. Meaning that I can do whatever I want, and either it asserts or it works. This should not be possible to do something and then accidentally have a race condition. That would be a bad design, I think. But yeah, deleting, I mean, if I call abort, it's not going to run the next state. It's going to delete itself as soon as you let it run again. So it's definitely true, I think, that if I call abort and then signal, then the signal might start running it again. Say, like, we cannot run, it's aborted. And then delete it. Abort is not a public function, I think. Or is it? What is public? Yeah. This function can be called from multiplex implementation, but also by a child task, and therefore by any thread. The child task should use a boost intrusive pointer to access this task. Ah, okay, so that's what I was thinking. A call to abort and finish will cause a task to not call multiplex implementation again at all after leaving it, except when finish implementation calls run again, in which case the task restarted from the beginning. We're going to do that. No, we're not. It is going to abort completely. But yeah, I was right. My feeling was right. We really need to increment the reference count to the task. Otherwise, there's a danger that we delete it. Is that even possible for Lambda? I can copy. I can make a copy of the. I can make a copy of the boost intrusive pointer by value. But then that must exist first. So that would mean I have to increment that counter extra times. Seems kind of silly. typical something that I should just add the support for, I think. All these problems only because I want to wait for multiple child tasks. Should make something that supports that, and then I can just use that instead of having to do such difficult things here. It's not possible to make a boost intrusive pointer that is not incrementing something. You just use the pointer. So this would simply increment it. And then immediately at the return here, decrement it again. Why not? It's still all not really that critical, I think. I'll guess I'll do that. And then instead of this pointer, I'll make a copy of parent. So you have the success here by reference and the atomic counter by reference. So these are just using a reference to that. And that is not working at all. Because that's in a scope that we are going to leave here. Dang. Yeah, they'll have to be passed to the pipeline factory as variables. Isn't it also in this state? Pipeline factory initialized? I think so. Being used there. You just copy everything by value now. Well, not everything. So specify it. So I'm having this pointer and the parent. And then this I can just run to call success. And what? Right, size is it not running initializations? Well, that's an amount that we're going to start up anyway. Yeah, okay. That looks okay, yes. So now we're calling run, and then when those tasks all finished, then this becomes 1. Or returns 1 rather, and becomes 0. And then all of them returned true. So this is still true, so we skip this one. Then we call signal on the parent. And the parent will start running again. Or it will just not wait. It really doesn't matter when that happens. If this all happens, this signal even happens before we enter this line or before we enter this line, doesn't matter. It's going to see the signal and then say, okay, you want to wait, but the signal has already happened, so we're not waiting. It's no race condition. And then we continue here, right? After the initialize has happened. And now the field should be something equally. So after set fill index, a call to run will run it again, and therefore call initialize implementation again, which will see that set fill index was called, and then we'll run these child tasks at a different entry, which is calling fill. So really what we want to do here is just call run again, I think, and then, well, the exact same thing. Although we want to run update after fill, so that must be part of the lambda. But this part can be copied from above here. So I'm going to need my parent again. And we need to set these variables again. And then we call this whole thing. Yeah, and then suddenly the name initialization is not a characteristic task. It's maybe better. I could just have pressed F7 actually. All right. This time we send the signal filled when they are all done. I also need to capture I, so I can do this inside a lambda. Yeah, and now we need to insert again a new state, I'm afraid. Yes, I did. Oh, this dead. Oh, this is on not having an opening brace. They can't have opening braces because of the go-to. And the go-to is there to make sure that I do not make that mistake of adding local variables. Jump to case level. Crosses. Initialization of. Ouch. Yep. So because I have a go-to here, I cannot declare any variables here. Well, there's no solution for that. Cannot have parent. Well, you can have here, but not down there. So instead of passing parent, I guess I'll just have to fiddle something with this. Parent is damn it, what is the class? Pipeline factory. What is it called, that function? I don't know. I remember how the other one is called. Allow deletion, I think. Yes. And allow deletion. File descriptor. Come on. Next. Allow deletion. It's called inhibit deletion. Can cause immediate allow deletion. Yeah, I think that's okay. So you can just call inhibit deletion here. That is a member function of AI ref count, which is a base class of us. Yeah. And then when we are done, we have to allow deletion again, but that cannot be done until after the parent was signaled for the last one. The other ones can do that immediately, like you can call allow deletion, and but not for the last one. Then we first have to do, oh well, actually that works. That works. So the last one does this first, call signal, and then we call allow deletion again. We're not accessing parent anymore after this. Just the last thing to do. Okay. Crash, crash, crash. And that's a difficult assertion, but it failed. So we're doing something wrong. If this fails, then run state didn't change and neither weight nor yield was called. Oh. Can we spot that? Well, I'm calling weight here. I think we have to run that in the debugger to see where the hell that happened. Or I should be able to see that. Which state we are in. Hotel. It's possible that I turned that channel off. Apparently, no. Yeah, it's on. Stateful task. Saw it. I saw it. Yeah, stateful task is on. And it is not being printed here. Thread pool 1. Could you be kidding me? Thread pool 0. Thread pool 3. Thread pool 1. Thread pool 1, it says running pipeline factory initialized. Entering initialize X, entering add uniform buffer, and so on and so on and so on. And then for a very, very, very long time, thread pool 1 is not printing any stateful task output anymore. So that was initialized, right? State that we were in. Yep. Yeah, initialized. Was it this one? Characteristics initialized. I think it was a different one. This one. Pipeline, let's say pipeline initialized. This is the one. So this is being run, and then we leave it without changing state. Well, I'm changing the state and I'm waiting. What more do you want? Okay, I don't see it. Definitely don't see it. Damn it. Hmm. It happens when I call run. I think I'm going to stop for today, or at least for the moment, because it's time to eat dinner. And I'm starving. I didn't eat breakfast nor lunch. So my stomach is protesting. I'll be back later. And this is, tough, I think. It's not something I can quickly fix. It's just nothing else to do here. I'll be back later. Thank you for being here, and I'll see you